Everyone knows the power of sun, but do you know the efforts taken to generate clean energy from sunlight? Come join us, the Team Blue Group B, on our field trip to St. Joseph CBSE School Manavalakurichi and Modern Power Solution Kavalkinara and understand the solar power generation. Sun is a star that occupies the center of the solar system and is an important source of energy for life on Earth. The sun produces an enormous amount of energy every day in the form of light, ultraviolet, and infrared radiation. The total energy radiated in a day is greater than the energy used on Earth in a year. Majority of the sun is hydrogen and helium atoms. Solar energy is produced through a process known as nuclear fusion, where hydrogen atoms fuse to form helium, releasing radiant energy. This energy travels at a speed of 3 lakh kilometers per second and reaches the Earth, which is 148 million kilometers away, in just 8 minutes. About 30% of the energy received by the Earth is reflected back to space. The land and oceans absorb a share of this energy, and the rest is trapped in the atmosphere and clouds by the greenhouse effect. Solar energy powers the water cycle, helps in wind formation, supports the plants in photosynthesis, and forms the base for life on planet Earth.
Now let's look into the timeline of solar power generation. Solar energy has been in use for a very long time. During the 7th century BC, magnifying glasses were used to concentrate the sun's ray to produce fire. The world's first solar collector was built by Swiss scientist Jorge de Saussure in 1767. The silicon photovoltaic PV cell was invented by Dreidel Capel, Cavil Fuller and Gerald Pearson in 1954. Solar PV cells were used to power satellites since 1958 and it became a vital technology for space research.
PV cell is the most widely used technology for solar energy generation. The word photovoltaic is derived from the words photo meaning light and volt a measurement of electricity. The PV cells are commonly made of silicon, an element found in sand and the second most common element on Earth. Solar cells are made up of thin layers of silicon wafers and the cells contain a, p and n-type region. These regions are positive and negative and allow the flow of electrons. When the PV cells are placed in sunlight, the light's energy excites the electrons and causes their movement. These electrons are passed through a circuit to generate electricity. Thus, the sun's light is converted to clean energy without the use of any mechanical functions. The PV cells are arranged together to form a solar panel, and the solar panels are installed as per our energy needs. Average efficiency of solar panels is between 18% to 22%. The types of PV cells are monocrystalline, polycrystalline, and thin film.
The different modes of solar power setup are on-grid, off-grid and hybrid. In the on-grid system, the solar setup is directly connected to the electricity line. An off-grid system has batteries to store the power generated from the solar panels. Then the stored power is used as per the need and requirements. A hybrid system is a combination of both batteries and direct supply.
Now let's take a look at component used in solar power generation. The PV panel is the heart of solar power generation. The panel are installed on the top of frames and positioned to receive maximum sunlight exposure. The total number of panels required is decided based on the electricity needs of the facility. A 1 kilowatt solar panel setup will have 2 to 5 panels and produce 3 to 5 units of electric current, an average in the normal day.
The generator power should be stored for the usage, and this is done with the help of batteries. Batteries are divided into dry and wet batteries. Number of batteries will be determined based on the power, backup equipment, and the electricity from the PV panels will charge the batteries.
The electricity generated by the PV panels can be varying depending on the intensity of sunlight. This uneven power generation can damage the batteries. To prevent this, charge controllers are used. They stabilize the power inputs to batteries, protect them from damage, and helps to increase the life of batteries. The solar panels generate direct current DC, and this has to be converted to alternating current AC for domestic use. Inverters are used for this purpose. An inverter is an electrical device that converts DC power to AC power. The electricity stored in the batteries is also in DC, and it has to be converted to AC for our use. The inverter plays an important role in the solar power setup.
Now let's look at how we get pollution-free energy from the solar setup. The 20 kilowatt solar setup on the terrace of St. Joseph CBSE School, Manavalakurichi, receives direct sunlight almost throughout the year. The 80 solar panels connected together produces between 70 to 100 units of electricity per day. Since the school operates predominantly during the day, the solar power generation helps reduce the majority of power charges. Particularly during the COVID pandemic, the school operated with zero power charges. The housing and industrial setup at Kaval Kinare is a 5 kilowatt plant that has 18 panels mounted on the rooftop. The setup supports the operation of a workshop, a painting unit, and also powers the staff quarters. This setup produces enough power for all the facilities to run free of electricity charges. The location also had a separate solar setup for the motor pump which supplies water to the needs of the business and homes. The field study clearly identified that energy generation from the sun is completely free of any pollution. There are no direct pollutants associated with the energy generation, and it explains why developed nations like China and the US are constantly promoting solar power generation. India is also not far behind and is currently in the third position in solar energy worldwide. India also has many new plans and targets to push solar power generation. It is almost the end of our field study, and we feel privileged to learn about the importance of the sun's energy. We thank the Kumari Arivial Peravai for such wonderful programs and encouraging everyone to explore and gain knowledge. We especially thank Engineer Brito and Engineer Shivakumar for spending their valuable time to guide us throughout this study. The learning cycle becomes complete only when the knowledge gained is put to use. Now that we have learned about the vital role played by the sun in giving clean energy, it is our time to act and make use of this valuable resource. We bid farewell asking everyone to create awareness about solar power and promote the use of this clean energy source. Thank you.